All right, welcome back, everyone, to the deep dive. Today, we're getting into a topic that's really shaking things up in the AI world. It's called synthetic data. Yeah, this is a genuinely groundbreaking area. It's rapidly changing how we gather information, how we use it, across pretty much every industry. So our mission today is really to give you a solid handle on this. We want to unpack the core ideas, talk about why it's suddenly become so important, look at some maybe surprising ways it's being used already, and of course touch on the challenges, the debates around it. The aim is basically to give you a shortcut to understanding this AI frontier, turning the complex stuff into, clear insights.
Absolutely. And it really is fascinating. It's one of those areas where the line between real world stuff and artificially created stuff is getting seriously blurry and in really powerful ways too. So if you're interested in staying up to date on the tech that's shaping things, well, this is definitely relevant for you.
Okay, so let's start right at the beginning. The basic question, what exactly is synthetic data? We looked into this, and maybe the simplest analogy we found is something like this. Imagine you're trying to teach a kid what a dog looks like, right? But you just don't have enough pictures of actual dogs.
Right. Limited resources.
Exactly. So what if you could use software to just create super lifelike dog pictures? Images that look totally real enough to teach the kid, but they aren't photos of any actual specific dog that exists. That's kind of the essence of synthetic data. It's data that's made artificially, not gathered from observing the real world.
Precisely. And it's not just pictures either. It could be text data, audio, video, even like tabular data. Think spreadsheets full of numbers. The main idea is that it's generated. Generated using AI models or simulations, maybe specific algorithms. You mentioned analogies. Think about, say, building a movie set versus filming on location in a real city.
Okay.
You can make that set look exactly like a busy street, shoot your scene, but you control everything. The lighting, the extras, the weather.
Right. You control the whole environment.
Exactly. That's the kind of control synthetic data generation offers. It's very precise.
That control sounds amazing. Almost like you could just magic up the perfect data set for whatever you need. But, does that mean it always reflects reality? With all the messiness and the weird outliers that real data has? Or is there maybe a risk you make something too perfect, too clean to actually be useful for training AI that needs to work in the messy real world?
So, okay, let's unpack this. How does someone actually, make this synthetic data? What are the methods? That's a great point about the realism, and it's definitely something the field is constantly working on. As for how it's made, there are basically three main approaches. First up is what's called simulation-based generation.
Simulation-based, okay.
Yeah, this is where you literally simulate realistic environments. Think high-end video games like stuff built in Unity or Unreal Engine. You can create virtual worlds with cars driving around, people walking, different weather conditions, whole cities even. It's super useful for things like training self-driving cars or robots, or even for augmented reality applications, places where you need to test lots of scenarios safely.
Makes sense. Safer than testing in the real world sometimes.
Definitely. Okay, second method, model-based. This is where AI comes in more directly. Specifically, we often see generative adversarial networks, GANs, being used.
GANs, right. Those are the ones where two AIs kind of compete to get better.
Exactly. One generates data, the other tries to tell if it's real or fake. And through that game, the generator gets incredibly good at making realistic output. Think about those deep fake faces you see online. Super realistic, but totally AI generated. That's a classic example of model-based synthetic data.
Got it. So simulations and AI models. What's the third way?
The third one is rule-based generation. This is a bit different. Here you use predefined rules, statistical models, maybe some parameters to create data that looks realistic according to those rules, even though it's completely fake. A good example is in healthcare. There are tools, like Synthea is one we saw mentioned, that can generate fake electronic health records.
Fake patient records?
Yeah, but they're designed to be medically plausible, statistically sound, based on known patterns of diseases and treatments. But crucially, no real patient information is involved at all.
Interesting. So simulations, AI models like GANs and rule-based systems. And I guess beyond those core methods, our research also mentioned specific, like APIs and platforms, companies offering tools to help generate this data, especially structured data.
That's right. There's a growing ecosystem.
Yeah, we saw names like Gretel AI, Mostly AI, MD Clone, Y-Data. Seems like there are dedicated tools popping up.
Definitely. It's becoming more accessible.
Okay, so that's the how. But it leads back to the big question, why? Why go to all this trouble making fake data when There's loads of real data out there. What's the real driver behind this?
Ah, the why. And this is where it gets really compelling. There are several key reasons that came up again and again in the sources. First, and maybe the biggest one, privacy matters. A lot.
Right, especially with things like GDPR and CCPA.
Exactly. Real world data, particularly in healthcare or finance, banking, it's incredibly sensitive, it's personal. Using synthetic data lets you train powerful AI models without ever touching or risking exposure of real individuals' private information.
So it bypasses a huge privacy hurdle.
A massive one. It's not just about compliance. It can actually speed up innovation in these sensitive areas because you're not bottlenecked by complex data anonymization or consent processes nearly as much.
Okay, privacy's huge. What else?
Well, sometimes data is just hard to get. Think about a startup. They don't have millions of users generating data from day one.
Or researchers studying a rare disease.
Perfect example. Or maybe you need data that's perfectly balanced across demographics, but your real user base is skewed. Synthetic data can let you generate large, diverse, balanced data sets almost on demand. It levels the playing field a bit.
That makes sense, filling the gaps where real data is lacking or scarce.
Precisely. And that ties into the next point, handling rare scenarios. We mentioned self-driving cars before. Think about training that car's AI. How often in real driving logs does it encounter something really unusual but critical, like a deer leaping out at dusk on a foggy road?
Hopefully almost never.
Right. But the car needs to know how to handle it safely. These are edge cases. They're rare in reality, but vital for robust performance. With synthetic data, you can create thousands of variations of that exact rare scenario and train the AI specifically on them.
So you can train for the unexpected, basically.
Exactly. You manufacture the edge cases. And then, related to the balance point, there's fairness and balance. Real-world data often reflects real-world biases, unfortunately. Maybe your data is mostly from male users or one particular age group. If you train AI on that skewed data,
The AI learns the bias.
it learns the bias. It can lead to discriminatory outcomes. Synthetic data offers a way to consciously rebalance data sets. You can augment the underrepresented groups to ensure the AI gets fair training data, leading to fairer AI systems.
Okay, so privacy, data scarcity, handling rare events, and improving fairness. Those are some pretty strong arguments. And this is where it gets really interesting, I think. Let's talk about where this is actually being used. Like right now, it's not just academic, is it?
Oh, absolutely no. It's very much in practical use today across quite a few fields.
Okay, let's walk through some examples we found. Healthcare seems like a big one.
Huge. We mentioned tools like Synthea simulating patient records. This is used for things like medical research, understanding disease progression, or even testing healthcare AI models before they're deployed in a clinic, all without compromising patient privacy. It's transformative there.
And autonomous vehicles. We touched on that.
Definitely. Companies like Waymo, Tesla, many others rely heavily on synthetic data. They create these incredibly detailed virtual driving worlds.
To train the cars on tricky situations.
Exactly. Extreme weather, unexpected obstacles, complex intersections, stuff that's hard or dangerous to encounter repeatedly in the real world. They rack up billions of virtual miles.
Wow. Okay, what about something like retail?
Yep. Retail and e-commerce, too. Businesses can use it to simulate how customers might react to a new product before they even launch it.
Like virtual focus groups.
Sort of, yeah. Or generating different customer personas and journey maps without needing invasive tracking of real users. Helps with personalization strategies.
Interesting. And finance. You mentioned privacy there.
Right. A key application is creating synthetic transaction data. Banks and fintech companies can use this to train fraud detection models much more effectively.
Without using real customer account details.
Exactly. They can model complex fraud patterns without exposing any sensitive financial data. It's a huge win for security and privacy.
And even just for general AI model testing.
Yeah, think about developing a new chatbot or virtual assistant. Before you let it loose on the public, you want to make sure it can handle all sorts of weird questions, different user moods, maybe even attempts to misuse it.
Right.
You can generate vast amounts of synthetic conversational data covering all those scenarios to really put the chatbot through its paces in a controlled way.
So it really seems to address those why factors we talked about, privacy, data gaps, edge cases across many different areas.
It really does. What's quite striking is seeing how this one core concept, generating artificial data, is providing solutions to these really persistent, difficult data challenges in such diverse fields.
But it can't be all smooth sailing, right? Like any powerful tech, there must be downsides, challenges, things to watch out for.
Oh, absolutely. It's definitely not a magic wand.
Yeah.
The sources we looked at were quite clear about the potential pitfalls and ongoing debates. These are the critical watchouts.
Okay, what are the main ones?
Well, first off, bias still exists. Or rather, it can be inherited.
How so? If the data is artificial.
Because often the models generating the synthetic data, like those yens we mentioned, are themselves trained on real data first to learn the patterns.
Ah, I see. So if the initial real data was biased.
The synthetic data the model produces will likely just copy and maybe even amplify that same bias. It doesn't automatically clean the data.
Hmm.
You still need to be incredibly careful about the source data and the generation process itself.
Okay, so garbage in, garbage out can still apply.
Pretty much, yeah. Then there's the tricky question of, is it real enough? Or maybe, is it too real?
Maybe.
There's this constant balancing act. The synthetic data needs to capture the important patterns and variations of the real world accurately enough to be useful for training AI models. It needs fidelity.
Right. Otherwise, the AI won't work well in reality.
Exactly. But if it becomes too realistic, especially if it's based closely on real sensitive data, you run the risk that it might inadvertently reveal something about the original data or even allow individuals to be re-identified somehow.
So it's a fine line between useful realism and potential privacy leakage.
A very fine line. And this ties directly into the next challenge, regulation questions.
Yeah, the legal side. How is this stuff treated?
Well, that's the thing. The legal and regulatory landscape is still catching up. It's pretty new territory. How do laws around data privacy apply to data that's technically fake?
Can synthetic data be used as evidence in court? Or for making critical medical diagnoses if it wasn't from a real person?
These are really complex, important questions, and frankly, the answers aren't fully settled yet. It varies globally, and standards are still emerging.
Okay, that's a big uncertainty. Any other major challenges?
One more key one is validation issues.
Validation, making sure it works.
Essentially, yes. How do you know if your synthetic data is actually any good? How do you measure if it truly represents the characteristics you need it to?
Right.
Ultimately, you usually still need some amount of real-world data, even if it's just a small, carefully controlled holdout set.
To check against.
Exactly. To validate that the synthetic data makes sense, that the models trained on it perform well when tested on real data, you can't operate entirely in the synthetic realm without some kind of reality check.
Okay, so it's definitely not a magic bullet then. It sounds more like a really powerful new tool in the toolbox, but one that needs careful handling and awareness of its limits.
That's a perfect way to put it. Powerful, but requires skill and caution.
And for people who are intrigued by this and maybe want to explore the tools, we briefly mentioned some names earlier. What were some of those platforms, again, that our research highlighted?
Sure, there are quite a few players emerging in this space, offering different specialties.
Yeah, we saw Gretel AI. They seem focused on creating synthetic data with built-in privacy filters, which addresses that concern we talked about.
Right, and Synthea, which we mentioned, is really prominent for simulating those realistic but fake healthcare records for research.
For the simulation side, especially visual stuff like for robotics or cars, Unity ML came up using their game engine tech for generating synthetic environments.
Yep, that's a big one for visual data. Then for more like business data, tabular data, mostly AI seems to specialize in generating synthetic structured data.
Okay.
And Y Data appeared to offer a broader platform, kind of integrating synthetic data generation into the whole AI model training workflow.
So quite a range of tools already. It definitely feels like a field that's, growing fast, lots of innovation happening.
No question about it. It's moving very quickly. And maybe, a final thought to kind of wrap this up, drawing from the sources we looked at, someone made the analogy. Just like CGI completely changed filmmaking, synthetic data is fundamentally changing AI development.
That's a strong comparison.
It is, but it captures the potential impact. It makes creating the data needed for AI faster, often safer from a privacy perspective, and potentially much more targeted and creative.
So the conclusion seems to be it probably won't replace real data entirely. That validation point seems key.
Likely not entirely, no. Real data still holds immense value, especially for grounding and validation.
But will absolutely enhance how we train AI, how we test it, how we deal with data limitations. It's a major evolution.
Couldn't agree more. It's a significant shift in how we approach data for AI.
Which leaves us with a final thought for you listening. As AI gets woven more and more into our daily lives, just imagine the possibilities. Imagine when we can ethically, efficiently create the exact data we need for almost any scenario. Think about it. What new breakthroughs, what insights, what applications could you unlock in your field, or just in understanding the world if the limits of data availability were suddenly much, much lower? What becomes possible when data scarcity is no longer the main barrier? Something to think about. Thanks for joining us on this deep dive.